Okay, we are expected to find the area of the shaded region. Foremost, we need two circles. So we have a circle. Now we've been given the following information. The radius of the large circle is 5 units and the radius of the smaller circle is 1 unit. Figure not to scale. Okay, so I'm going to take this as a center. This is going to be O and this as the center, and this is going to be P. Now since there is a point of tangency between the circles, if I were to draw a line connecting the centers, then the line that I use will actually pass through the point of tangency. So in other words, if we were to draw a line through the point of tangency, then that line will connect the centers of the circle. So that is a geometrical property. Now what is actually required here in this question? The question wants us to find the area of this shaded region. So this is required in this question, right? And you have this tangent also going. So I will take this point of tangency as T and point of tangency here as some S. Now what we have to do is we have to evaluate that. In other words, find this region. Now foremost, what we have to do is we will have to connect the point P with T. Now since this is a tangent and this is the radii, they will make an angle of 90 degrees, okay, by geometrical property. So this is clearly going to be 90 degrees here. So having got that, what I would next do is I will actually drop perpendicular from this point to this point of tangency between O and S. So I will also connect the point between O and S. So this is going to be 90 degrees. Now having got that, as I mentioned to you, I will drop a perpendicular, okay. If I were to drop a perpendicular, then I would be able to utilize that perpendicular in extrapolating the unknown. Okay, so let me do that. Because of the complexity of the figure, it is imperative that we understand that figure is not to scale. Okay, so having mentioned that, let me write down the radii. So clearly TP is going to be 1 unit. This distance is also going to be 1 unit, right? This distance is the radii because P is the center. But we cannot outrightly say this distance. We do not know this distance, but we can connect, since I mentioned to you by the geometrical property, there is a line, a point of tangency between two circles, and if I were to draw a line through the point of tangency, then that line would actually connect the centers of the circle. So I can actually connect O with P. Now the radii of the large circle is given as 5 units, so this is going to be 5 units. This drop is going to be 1 unit. So this distance is going to be 4 units. Okay, as I mentioned to you, figure is not to scale. So this is 5 units. Okay, so this is going to be 1 unit, so I will write that 1 unit over here, and this entire OP is going to be equal to 6 units, right? Now I'm going to take this angle as alpha. I need this angle because of this drop, this perpendicular, right? So this is clearly going to be 90 degrees. This is 90, but we need to get this alpha. We need to get this angle. Okay, so how do we get this angle? Now we know this is actually a right triangle. Why do I say that? Because of this perpendicular, this is going to be 90 degrees. So if I were to draw this in this fashion, this is exactly how the angle is going to be looking at. So this distance is alpha, this distance is, or this angle is 90, and let me take this as some A. This is A and this is O and this is P, and this entire length, right, this entire length is 5 positive 1 is 6 units, and this length is 4 units. We need alpha. So we have this trigonometrical property. What is that? Sine alpha is opposite side by hypotenuse. So sine alpha is equal to opposite side is what? 4 units divided by 6, right? So 2 times 2 divided by 3 times, so this is 2 over 3. So I got sine alpha is 2 over 3, therefore alpha is equal to sine inverse of 2 over 3. So we need to use our calculator. So 2 divided by 3, that is giving us a value of, I'm going to take it as 0.67. So shift sine inverse of 0.67. What is the value? That is giving me an angle of 42.1. So I will approximate it to 42 degrees. Okay, so that means this entire sector is going to be 90 degrees plus 42. That is going to be 132 degrees. Now you might be asking me, why do we need this sector angle 132 degrees? Why? Because we are asked to get this shaded region. So how do I get the shaded region? Now if you were to see this figure, consider TPOS. What is this? This is a trapezium. Okay, which is a trapezium. Now the required shaded region from the area of the trapezium, I would want to take away the 2 green regions. So this is a green region. From the trapezium I will take away this, and I will take away this region, and then I will take away this region. Okay, so for that I need to get the area of the sector. So you can go through this and see if we are on the right track. So let me write the formula. Required area is going to be, from trapezium area you subtract the area of the 2 sectors. Now I'm going to take this as some Q. This particular region is some Q. Okay, so let me get the area of sector TPQ. Area of sector TPQ is theta over 360 times pi r squared. This is a formula. Now theta is 132 degrees. This entire angle is 132 degrees. So 132 degrees divided by 360 multiplied with pi. R, the radii is 1 unit. So I'm going to have it as 132 divided by 360 times pi. Now I can reduce this by 4. 4 3s are 12 and 1 there, 3s are 12. 4 divides here 90 times pi. 3 divides here 11 times, 3 divides here 30 times pi. So this is the area of the first sector. Now let me go and get the area of the second sector. Area of sector, this is going to be SOQ. Okay, now we need to get this angle, right? We need to have this particular angle recorded. Now this is 90, this we have taken it as 42 degrees. So angle at O is from 180 we subtract 90 plus alpha. 90 plus alpha is actually, we're taking it as 42. So 132, we subtract 132 to get this angle. So that would give me 48 degrees, right? Angle at O is 48 degrees. So this angle is 48 degrees. So sector, area of sector, what is that? SOQ. So that is theta over 360 pi times r squared. Now theta is 48 degrees divided by 360 pi times. Now the radius, what is the radius here? 5 units, right? So that is placed here. That's going to be 5 squared there. Alright. So this is equal to 48. 4 divides here 12 times, 4 divides here 90 times. So 12 over 90 pi times 25 units. 3 divides here 4 times, 3 divides here 30 times. So 4 pi 25 divided by 30. Now 2 divides here 2 times, 2 divides here 15 times. So 2 pi 25 divided by 15. And 5 divides here 3 times, 5 divides here 5 times. So 2 pi times 5 times divided by 3, which is 10 pi divided by 3. So this is the area of sector SOQ. Now we need to add the two sector areas. So area, total area, right? Total area of sectors is this one is going to be 11 pi over 30. I mean, that's what we got. So 11 pi over 30 added with 10 pi over 3. So if we were to take the LCM as 30, this is going to be 11 pi. 3 divides here 30 10 times, right? And you have 100 pi. So 111 pi divided by 30. This is what we have got. So 9, 10, 11. So 3 can be used to divide this. 3 3s are 9, 10, 11, 21, 7. 3 divides here 10 times. So it's 37 pi divided by 10. Now we need to get the area of the trapezium. So area of trapezium, what is the formula? Is half times the base 1 plus base 2. So we need to know this height. So base 1, base 2 is known, right? So these are the two bases, and then we need to know this height. Okay, so the question is, how do we get that? We can easily get that by considering the triangle PAO. Okay, so let me go to the next side of the sheet. So I'm going to consider, this is going to give me the height, because so these are the two bases, right? Base 1 and base 2, and this TS will give us the height. So that TS is actually obtained by considering PAO or OAP. So consider, this is how it looks, right? The triangle looks like this. So this is P, this is O, this is A, this is 4 units. This length is 6 units. This entire length is 6 units. Okay. So that's there. Now this is 90 degrees. So by Pythagoras rule, theorem or rule, what do you got? You got OA squared plus AP squared is equal to OP squared. So this squared, 4 squared, plus AP squared is equal to 6 squared. So this is 36 negative 16, which is going to give me 20. Now this is AP squared. So AP is equal to root of 20, which is 4 times 5, which is root of 4 times root of 5, which is going to be 2 times root of 5. So this is my height. H is equal to 2 times root of 5 is my height. Now, so area of the trapezium, therefore area of trapezium. So what is the area of trapezium? Base 1. So what is the base? First base 4. This is 1 unit, right? So this base is going to be 5 units. This is going to be 1 unit. So 5 positive 1 divided by 2 multiplied with 2 times the root of 5. So 2 gets cancelled. 5 positive 1 is 6 times the root of 5. Square units. So therefore shaded region, required shaded region area. So required shaded region area is equal to, from this you take away, what you need to take away? You need to take away total sector area, 37 over 10 times pi. 37 over 10 times pi. Okay, so you will have to take away this. So this is going to be, if I were to take the LCM as 10, this will be 6 times the root of 5 times 10 negative 37 pi. Okay, 37 pi. So let me write that down. So it's going to be 60 times the root of 5 negative 37 pi divided by 10 square units. Okay.